Welcome back, pre-calculus. I've had enough of the graphing limits stuff. I think we've covered most of the ground there. We are moving on to some analytical, computational techniques now that I don't think you guys will find too bad, but we'll see. This is probably going to be split into a series of videos, and the assignment, it is kind of lengthy on Google Classroom, but I'm giving you guys till Monday to do it, so plenty of time. All right, so think about it like this. We're computing limits, but not with a graph. So we almost have to use our imaginations here. We're thinking to ourselves, each one of these expressions can create a series of dots on an XY plane, fleshed out in a curve, and it can be like, oh, there might be some asymptotes on this one. Maybe there's a hole in the graph, that kind of thing. So this is where your knowledge of graphing rational functions really comes back into play. If you remember in the graphing sense chapter, we had some where if there's kind of like a polynomial on top and like a linear thing on the bottom, or even vice versa, that hey, if I can factor the top in such a way that makes it simplify, remember when we crossed out factors, that meant something for the graph. And hopefully it's coming back to you now. So what you have to do is come back to this whole skill of, can you factor? Okay? So, I'll write this a little bit bigger so you can see it on the video. These are the notes that are attached in Classroom. So what I want to do is investigate the top. Does x squared plus x minus 6, does it share a factor with the bottom? Can I rewrite this to where it's x minus 2 times something so that we can cancel out what appears to be a domain issue? Like if the limit matches the thing that makes the bottom 0, you know you have to cancel that out in order to actually compute this limit properly. So ask yourself, do you remember how to factor? If the answer is no, I will briefly go over it, but I think you guys should just kind of like explore that on your own. So over here, check this out. I'm going to put a 1 in front of that x. Now there's a couple different ways to do this. There's guess and check. I think the one where you split the middle apart into two factors is ones you guys are most familiar with, so I'll do that. AC factoring means what multiplies to give me 1 times negative 6 and adds up to give you the middle B term, which is 1. Well, there aren't too many factors for negative 6, right? 2 and 3 and 1 and 6. Well, if it's a negative 6, 1 has to be negative. So negative 2 times a positive 3 gives me 1. So that means that you replace the middle with negative 2x plus 3x. This is still 1x squared. This is negative 6. Then what you do is you factor by grouping. You ask yourself, what do these two share? They share an x. There's my GCF. The leftovers would be x minus 2. What do these two share? They share a 3. The leftovers are divided by 3. You get x minus 2. It's x plus 3 times x minus 2. Okay. There's your crash course in factoring. It's kind of your responsibility now to know how to do that from now on. Hopefully you recognize that there are some shortcuts. For instance, see this? Minus 2 and a plus 3. It ends up being a minus 2 and a plus 3. That only works if the leading coefficient, the x squared, is a 1. You can't do that if there's like a 3 or a 2 or a 5 or anything except a 1. So this is x plus 3 times x minus 2 over x minus 2. These factors now cancel. So you've canceled out the domain issue that made plugging in the limit right away impossible. See, that's kind of the idea of the limit is, if there's no domain issue, just plug it in. Plug that 2 in to wherever it seems to fit the polynomial. That didn't work, but now that we've canceled it out, you can just plug the 2 right in here. Okay, the limit's 5. And hopefully you're remembering we graphed these. This is how you graphed it. You said it's now a line x plus 3. So its y-intercept is 3. Its slope is up 1 over 1. But then at x equals 2, there's a hole. There's a hole right here. Ta-da! So the limit from the left and the limit from the right match at 5. So that's really what's happening with this particular situation. Now, I'm not saying you got to graph it every time. I'm just trying to reinforce this idea that you are just computing the same kind of graph-related limits in a completely different context. All that was geometry. Now we're talking staying in the realm of algebra, doing some gymnastics of factoring, conjugate, other stuff you'll see on this example, on this problem set. But it's not too bad. We're talking about the same concept, just a different avenue of finding it. Let's move on to 2. So hopefully on that previous example, you're like, I gotta factor this thing. Well, the top really can't be factored. I mean, you can take stuff out of it, but you can't really use the AC method. The bottom, however, hopefully there's an instant recognition that those are differences of squares. You don't need to go through the whole process of factoring for that. It's just a recognition of x squared's a perfect square, 25's a perfect square. They're separated by subtraction. So that creates x minus 5, x plus 5. If you're not quite sure what's up with that, please go to YouTube and put factoring difference of squares. Somebody will explain it to you. Now the top is 5 minus x. It is almost x minus 5. What you got to do is you got to do some finagling. You got to take this 5 minus x, which is really negative x plus 5, and then ask yourself, can I take out a negative 1 from both parts of this? The answer, yep. Take out a negative 1. Oh, it's x minus 5 now. We can cancel out the thing that created the domain issue. If I tried to do 5 minus 5 on the bottom, 0 is what would come up. But since I factored it out, negative 1 over x plus 5, a straight plug-in of 5 right here yields negative 1 over 5 plus 5. It's negative 1/10. Yay, we got it. So keep in mind, too, with this graph, there still is an asymptote at negative 5. That negative 5 on the bottom, that x plus 5 didn't cancel on the bottom. So you still have 1, 2, 3, 4, 5, an asymptote there. And then there's just a hole at wherever x equals 5. So I think the curve pattern's something like this. But then all the way over here at 5, there's a hole in the graph. I'm not exactly sure if that's correct. It could be flipped, but let's move on. All right, with these 2 examples, what we have to do is we can't do factoring in the strictest sense of the word. When you see the square root of 1 minus x minus 1 equals x over x up here, we have to think a little bit outside the box. And if you remember, we did some Khan Academy SAT prep earlier this year where we talked about like imaginary numbers, and every once in a while, this showed up. And it's like, we need to get rid of the root 2 on the bottom. We need to rationalize it. We need to make sure that there's an integer value on the bottom. Well, what we did in that case was we multiplied by the conjugate. Now, the great thing about the conjugate is it creates a difference of squares. And difference of squares always just basically map out to square the first term, square the last term. So this comes out to be 1 squared, which is 1, minus root 2 squared, which is just 2. Well, that was helpful. Because now we have an integer on the bottom. Now, we can manipulate that to try to do something with number 3. We could say perhaps if I multiplied by the conjugate on the top, which is not the inside of the root that's affected, but it's this difference between the root and the non-root. If I multiply by that on the top and on the bottom, perhaps this x that's inside the root will somehow break out and maybe cancel out with our pesky domain issue. So like I said, the conjugate is a difference of squares. You square the first, root 1 minus x times root 1 minus x is 1 minus x. That's these two multiply together. And then these are squared as well. The bottom is going to be x times, now this thing, there's no need to distribute that x. So don't do that. Hey, 1 minus 1, that's 0. Yeah. This x factors out this x down here. X divided by x is 1 over 1. We just canceled out the domain issue. So there's now a negative 1 on top. This 1 just kind of gets absorbed into the multiplication. Plug the 0 in for the x here. So now it's negative 1 divided by root 1 minus 0 plus 1. It's negative 1 over root 1 plus 1. Root 1 is 1. 1 plus 1 is 2. It's negative half. All right? This is kind of a typo here. I meant to make this negative 2. It's not kind of a typo. It is a typo. All right, hit pause and try that one on your own. All right, let's see what you got. So we're multiplying by the conjugate up top and on bottom. That means that you're basically getting rid of the roots when you multiply these two together. So you're going to have x plus 11. And then you're going to take the 3 times the 3, which is 9. It's always subtraction. The bottom is left with x plus 2 times that really unpleasant part down there. It's, dare I say, ugly. All right, so 11 minus 9 is 2. It canceled. Your domain issue is gone. You're left with a 1 on top. So then take that negative 2, plug it in for x. So that's 1 over root negative 2 plus 11 plus 3. That's root 9, which is 3 plus 3. It's 1/6. All right. I'm going to stop the video, but then keep talking through these notes.